Okay, so I've posted homework 5 onto CCLE, and I want to spend time in class talking about it, just because in the past I've assigned similar homework assignments, and I probably didn't spend enough class time going over what is actually going to happen in the homework, and so I had a lot of confused things. So this assignment keeps evolving as time goes on. Okay, so anyway, there's this board game called Monopoly. I imagine many of you have played it. If you haven't played it, you can watch videos on Amazon on how it works. But basically, the board looks like this, if it will load. Okay, this is what the game board looks like. You start at go, and you roll 2 dice. You roll like a 6, and you go 1, 2, 3, 4, 5, 6, and you land here. And you keep going around the board in a circle, okay? And if once you reach the end, you just keep going around and around. And during the game, you purchase properties and you sell them, and you charge rent and you trade and all of this. And in Monopoly, you're trying to be the evil businessman and make all of your opponents bankrupt. Okay, that's the purpose of the game. In your assignment, I am having you guys simulate a bunch of rounds of Monopoly, and I just want to find out which properties are most likely to be landed upon and which ones are less likely to be landed on. This has been studied already by other people who've written books about playing the game Monopoly, and I don't know, like there's like self-help books on business, and it's like everything I learned from business I learned from Monopoly, which makes me question how much you learned about business. But there's anyway, so it's been studied. You can go online, and there's a general consensus about certain properties that are more likely to be landed on and certain properties that are less likely to be landed on. I think this is a very good example of a computational statistics problem. This is a problem where, as far as the rules of probability go, we could apply them and figure out the probabilities of rolling each thing. We could turn there's different rules about, rolling again, different rules about, drawing cards that affect where you land and going to jail and how that affects things. We could turn all of those things into little mathematical equations and pieces and put them together and try to figure out from an analytical perspective the probability of each of these squares, okay? It would be rather complicated, and perhaps you could also make a mistake. Well, with computational statistics, you can also make a mistake. But I think this is a good example where we can use the computer and its ability to generate a bunch of simulations to get at an answer that reflects what happens. Okay, so we can say, we could play 1,000 games or simulate 10,000 games or something and get an idea after playing so many games which spots are more or less likely to have been landed upon. And so I want to cover how the rules work as far as this goes, okay? And so your assignment is going to be to write some code in R, and I've provided some starting code, and I'm hoping that the starting code will be beneficial to you guys in accomplishing this task, okay? And so let me just talk about how the board movement goes. So you start at go. You roll 2 dice, okay? So there's 36 combinations. You can roll anywhere from a 2 to a 12. And whatever numbers show up, you move that number of spaces, okay? There's one spot that says go to jail, okay? If you land on this spot, you immediately go to jail, okay? So you never end up here, okay? If you keep track of how many times you land on a space, this thing will be landed on 0 times, okay, at the end of the day, okay? And instead you would have moved to jail. Okay? When you roll doubles, so rolling doubles is rolling something like 2 4s or 2 6s, or you roll the same number twice. It's not even numbers, but you roll like a 3 3. Okay? In that case, you get to roll again. So you roll 2 3s, you end up right here. You roll again, and as long as you keep rolling doubles, you keep going forward. However, if you roll doubles 3 times in a row, okay, as soon as you roll doubles for that third time, you immediately go to jail. So if you roll 2 3s, you'll move to Oriental Avenue. You roll 2 3s again, or let's say 2 4s, you would move forward 8 spaces. So you go 1 2 3 4 5 6 7 8. You would end up here. So that means you've rolled doubles twice. And then let's say you rolled 2 1s, okay? Before you even move to St. James Place, because you've rolled doubles for the third time in a row, you immediately go to jail. Okay, so you don't even, so you start on go and you roll 2 3s, you go to Oriental Avenue, you roll 2 4s, you end up at Virginia Avenue, you roll 2 1s, you don't go to St. James Place, you immediately go to jail. All right. Yes, question.
What if you rolled on a community chest or a something? Would you get to draw the chest or the chance and then?
Yes. So, okay. So, the chance and community chest. So there are spots called community chest and chance. Okay, and they're around the board. And if you land on these spots, you draw a card. Okay. So let's say you rolled a 7. You would go to chance, and then you draw from the chance deck. Okay. So when you land on chance, you would count, I have landed on chance, and then you draw a card. And now if you draw a card, sometimes the card says, second place in a beauty contest or something, and you get $10. What? Yeah, well, this was made in the 19 whatever. So, so you get $10, and you just stay on that spot, chance. Okay. Other times it'll say like move to boardwalk. Okay, it'll say take a ride on the boardwalk. So or take a stroll on the boardwalk, and then so immediately you would teleport to the boardwalk space. Okay, and so in that example, you would say I landed on chance, and you'd put a tally for chance, and then you would move to boardwalk, and you'd put a tally at boardwalk. Okay, so because we're trying to keep track of all these spots that we land. So you roll, you land on community chest, you'd put a tally at community chest. If community chest says collect $100 or something, then you don't put another tally at community chest, you just have one tally there. Okay. However, if it says you landed on community chest, you'd put a tally there, and then you draw the card and it says go to advance to go, then you move to go and you'd put another tally at go. Yes.
Why do you not want to keep track of the number of times that you land on the go to jail, but you want to keep track of the number?
No, we do. Okay, so you just never end your turn on go to jail. So it's not that we don't want to keep track of it, it's just according to the rules, you never end your turn on go to jail, so this will never accumulate tallies.
But then, like, when you would say that you landed on chance and that you landed on boardwalk?
Yes, well, at least this is how I'm interpreting the rules, in that when I land on chance, we'll count a space there, we'll draw the card, and then we'll move to boardwalk, and we'll put a tally there. Okay? Yeah.
So when you roll a double, you know how you go again?
Uh-huh.
Count that space that you landed on?
Yes. So when you roll double, rolling double just means taking another turn entirely. Okay? So let's say, you roll doubles, you somehow end on chance, you put a tally there, you move to boardwalk, you put a tally there, okay? But because you rolled doubles, now you go again. And then, maybe in that case, you roll and you land on community chest, okay? And then so you put a tally there, community chest moves you to go, you put a tally there, okay? So rolling doubles means you take an entirely another turn, turn again. Okay, as far as jail goes, this is maybe the most complicated thing, is you land in, there's just visiting jail. So if you're just driving through and you land on the jail space, you are not in jail. You are, quote, just visiting jail. Okay? However, if you do something like you land on the go to jail spot, or you draw a card that says go to jail, then, or you roll doubles 3 times, then you end up in jail. Okay? And when you're in jail, you cannot get out of jail until you roll doubles again. Or you pay a $50 fee and you get out of jail. Okay? And there's been different commentaries written on the proper strategy here. And that is, should you pay the $50 immediately and get out of jail, or should you stay in jail as long as possible? And you're allowed to stay in jail up to 3 turns. Okay? On your 3rd turn in jail, you get out. Okay? So just for the simplicity of the simulation, we'll go with the long stay in jail. So this will cause jail to be landed on a whole bunch of times. And so in this case, if you end up in jail, you can roll doubles and you get out. And this is a little funny thing. If you roll doubles to get out of jail, you don't take another turn. Okay? So if you're in jail and you roll double 3s, you move to St. James Place, but that's the end of your turn. You don't take another turn after leaving jail, if that makes sense. Okay? These are just the rules of the game as detailed in the booklet. Okay? If you don't roll doubles, you stay in jail. However, on your 3rd turn in jail, you will get out no matter what. Okay? And so in that case, whatever you roll, you just move. And that's how you exit jail. So you'll have to keep track of how many turns you've been in jail, so you know when to get out. Yes.
So if you roll a double but you want to stay in jail, are you just not rolling at all?
No, if you roll doubles, you have to leave jail.
You have to. Okay.
Yeah. So on your turn, you have to roll the dice, and if you roll doubles, you have to leave jail. Now, when you're actually playing the game Monopoly, there might be a point where you want to stay in jail and you don't want to leave jail. Okay, there's just this funny situation where maybe all of the properties are owned and you don't want to actually exit jail. But if you roll doubles, you have to exit jail. Okay, and if it's your 3rd turn, you have to exit jail. Okay, so probably there's going to be a condition where it says if 3rd turn in jail, you must leave. Yeah. Yeah, if you don't roll doubles and you remain in jail, you tally. You put another tally at jail.
And if you're just visiting, do you tally here?
Yeah, if you're just visiting jail, we'll put a tally on jail also. Yes.
Is there a decomposition of the chance? So that 5 of the chance cards.
Yes. I have all of the chance cards listed out and they tell you exactly what they do. Yeah. Question. Yeah, so I'm explaining the rules, and then now I'm going to talk about writing the simulation here. Okay. So those are the rules, at least for movement. Okay. Is that okay for movement? Yes.
So we're not considering the whole pay $50 to get out of jail. Right?
Yeah, we're not considering money at all. Okay, that would make this much more complicated. maybe an advanced project you can program your own game of Monopoly in R, and that involves trading and AI strategy. But and then you'll get a cease and desist letter from EA or Hasbro. Okay. So anyway, I've created some code here, okay, under Monopoly Getting Started example, okay, and the first 3 lines are game board, chance deck, and community deck, okay. So let me just load these up here, okay, and they're just huge things, and if if I click View the Chance deck, you'll see I've got index. There's 15 cards in the chance deck, and these are the 15 cards. And I've arranged them so that the first 9 are the ones that involve movement, and the remaining 6, these are ones that do not involve movement. Okay, so you'll want to set up some kind of thing, and you can hard code this and just say, if for the chance deck, I'm imagining that you're going to do like sample 1 through 15, size equals 1. So you're just drawing one number out of 1 through 15. And for simplicity, we will say sample with replacement. This is technically not how it goes, but then you would need to build a reference class object for the chance deck, which is doable, but I won't make you guys do. Okay. So anyway, you could just say something like, if, say that the card will be sample 1 through 15, comma 1, and you can say if card equals 1 equals 1, then your new position will be advanced to go, so your new position will be spot 1. Okay, or if it's Illinois Avenue, then you're going to be on spot, I don't know, 22 or something like that. Okay. Same thing with the community deck. In the community deck, there's only 2 cards that involve movement. That's advance to go and go to jail. Those are the only ones. Again, go to jail means you are now in jail, not in the just visiting, but you're actually in jail, and all of those jail rules apply. Yes?
Should we take the get out of jail free card?
Yeah, don't take that into account, okay? Again, we're just simulating board movement. We don't want to complicate things. Yes?
As in this fact, you also said that you will only go to that position if that position is in front of you. So say if you happen to land on a chest that's on like the 30th position, but then you draw the card of go to go, which is the first position. Will the first position considered as being in front of you or behind you?
It's always in front of you. It's always okay. So in the Monopoly rules, it's always move forward is the thing. Okay. So if you roll like if you land on chance and it says advance to go, technically your board movement has to go around this way. Okay. There's only one thing that says move back 3 spaces. Otherwise, it's always moving forward. So there's a card in chance that says move to the nearest railroad. Okay. Now, when you look at the board, it feels like the nearest railroad is right here. But because it's behind, we're always moving forward, the nearest railroad is this one. Okay? So that's just the rule here. Okay? If you're here and it says move to the nearest railroad, you move forward to Reading Railroad. Okay? That's the rules. Okay? If you draw chance here and it says move to the nearest utility, there's 2 utilities, the electric company and water company or waterworks. You move forward to the electric company. That's what the movement does. Okay, so I have the chance decks, the game board, chance deck, and community deck programmed for you. Okay, and I've also programmed 2 dice functions for you. Okay, it looks a little bit more complicated than it needs to be. Oops. And so this is the regular old dice, and inside dice I'm sampling the numbers 1 through 6 twice. Replace equals true. Okay, and that's going to give me the faces of the dice 1 through 6, and it's going to return at the end of dice. It returns a list. Okay, which is the faces, whether it's doubles or not, and that's if the 2 faces are true equal to each other, we say doubles is true. And then the movement is how many, the sum of our faces, okay? And then there's also a verbose option, which will print out what happens versus what doesn't. So if I run dice like this, it will say I drew 2 3s, rolled 2 3s, doubles is true, movement is 6. Okay, I can roll dice again. It says 4 6, that's false, but the movement is 10. Okay, if I do dice verbose equals true, or if I just write dice true for verbose true, then it prints out this part, rolled is 6 6. Okay, and so you can just do something like this. Roll is dice, and so when verbose is true, it will tell you what has been rolled, which may or may not be helpful as you're running your code. If you set it to false, or if you leave it in the default state, the roll gets updated. You can see the movement, but oops, you're not going to see what happens. Okay, and so this keeps updating here. So the verbose option just allows you, as your code is running, to see what's going on here. Okay, that's what the verbose option does. So verbose helpful when you're doing your programming, because sometimes you're doing things and you're thinking it's working correctly, but it's not. When you look at your results, you're like, this isn't quite right. Verbose helps you figure some of these things out without necessarily having to enter debug mode. Okay. I also, because when I was working on this, I found it, sometimes I wanted to put my piece into certain positions to test out the functionality, right? Like I wanted to land on the chance space to see if my chance thing would work. And it was it was difficult to do that with just the regular old dice. So here I have manual dice, and I'll show you how this works, okay? But with manual dice, you can actually specify the actual rolls that will happen, and you can test things out that way, okay? All right, so remember all of that reference object-oriented stuff from a couple weeks ago? Okay, this is where a reference class is going to be very helpful, okay? Because you can build a reference class for players, and if in a two-player game, you're going to have two separate players, and each is going to have its own statuses to keep track of, right? And I mean, that's why it's so hard if you're playing a game of Monopoly and then you like take a break to eat dinner and then you come back, you've forgotten all of your states, right? So with a reference class, this is the game is keeping track of all of these states here, okay? So in the beginning, I've only created two statuses or fields for you to keep track of, okay? And that is the position and whether verbose, yes or no, okay? As far as a player goes, there are much more things that you want to keep track of, right? You got to keep track of whether you are actually in jail or not, okay? Maybe you want to write some of these things down as far as things to keep track of, right? So you want to keep track of whether you are in jail or not. You want to keep track of what turn it is that you're in jail, okay? Because obviously when it's your third turn, you need to get out of jail. You want to keep track of how many times you've rolled doubles, because if the time you roll doubles on the third time, you're going to get sent to jail. I don't know. Yes?
Is it consecutive doubles? Or is it
Yes, consecutive doubles. It's not like you roll doubles in the beginning and then you play a few more rounds and then you roll doubles again, and then now you're like, oh gosh, it's not like fouls, accumulating fouls in basketball or something. It's consecutive, doubles consecutive, yeah. I'm trying to think of some of the other things off the top of my head. But yeah, definitely how many doubles you've rolled, whether you're in jail or not, the number of turns you've been in jail. Things like that, okay? And so here I've set a reference. So here I'm just keeping track of the position and whether we want it to be verbose or not. And I've created just two methods, okay? And you'll probably want to... I encourage you to think about this and make your methods wisely, I guess, okay? And it's probably better to have more methods here than to have a whole bunch of code later, okay? I'll tell you, my final solution for getting this whole thing running is about 250 lines of code, okay? That's not necessarily a challenge or a goal for you guys to achieve, okay? But I just know that in the past I've gotten submissions that were like 1,000 lines of code, and it didn't have to be that long, okay? The 1,000 lines of code worked sort of, and it's fine, but I think my 250 lines, it's a little bit easier to get through, okay? And a lot of those lines were just detailing out what each chance card does. Okay, so these are I have two methods associated with player, okay? I've got move n, which is your standard movement thing, which is going to take your current position, add n, which is how many spots you're going to move, so +7, and then you update your position there, okay? And again, because this is a reference class, we use the super assignment here, okay? And here I have if position is greater than 40, meaning if we've looped around the board, right? Because there's 40 spots on the board, so once I've passed go, I have to subtract off 40, and I've started the loop over again. So that's what this does, okay? And for the verbose, I'm just saying, player is currently at, spot 3 or whatever. player moves 7, player is now at spot 10. Okay, that's what I have if it's verbose. Otherwise, it's just going to do this silently. Okay, and the verbose option allows us to kind of see these things. Okay, and then I also have another one, and this is for things like drawing a chance card that moves you to another spot. Here you're just going to say go to space N. So if it says, you know, the chance card says go to boardwalk, which is the last spot on the board, spot 40, we would just say our position is now spot 40. Okay, so these are my two methods. So I'll enter that. And then here I can say create a new player using player $new. And so now player 1 is a new reference class. Okay, and so with player 1 I can do things like player 1 move underscore n, and I'll do move 5. So if we roll 5, no, wait, what did I do?
You didn't put player 1.
Oh, thank you. Player 1 move n, and so it says player is at 1, moves 5, player now at 6. Okay, and that's with the verbose option. Okay, and if I do move 10, okay, player's at 6, player moves 10, player's now at 16. So we can do all of this, and then later on we can just kind of say, you know, player, what's our position of player 1? It's at spot 16 and things like that. Okay, so these are the fields you'll want to keep track of. And then as far as keeping track of where we've landed, I'm going to create a new reference class called tracking, and here it's just, I'm going to just have a vector that is that's just going to be of numeric values here. Okay, so here tally is numeric, and the method is just going to be increase count on spot n, and all we're going to do is we're going to take the tally in position n and add 1 to it. So here's a reference class. So space tracking, I'm going to create a new space tracking thing. So if I do space tracking, okay, really it's just a vector of 40 values for each of the 40 positions, and we're going to just want to increase something here. So let me kind of go back, and we'll just say we'll create a new player. Okay, and basically my simple turn will be, this is the most basic of turns. In taking a turn, it's going to be a function. We're going to give it the player and the tracking thing that we're using. Okay, so in this case we're going to give it player 1 and the space tracking reference class that we're giving it. Okay, or reference object. And in a turn, all we're saying is we're going to roll the dice. We're going to look at the movement on the roll, and with the player we're going to move that space, that many spaces, and then after we move that spaces we're going to increase the count in our tracking thing. Okay, so this is the most basic form here, right? So all we're doing is we're rolling the dice, where we increase, we move our player, then we increase the tally. So this is my take turn. Is this okay so far? What's happening? All right, and so here, yes. Wait, question?
How do you update the tracking thing?
So tracking is another reference class, right? So we're using, I've got two reference classes here. I've got a reference class for the player, and I've got a reference class keeping track of all the spots we've landed. And really, we're only going to be using one reference class object for the tracking, because we just want to keep track of where we've moved for just one of these things, or just for the board in general. And inside the tracking reference class, I have one method that says increase count. And all that does is it takes the number in the tally vector, right? So I've got a field called tally, which is a vector of 40 values, and they start off all zeros, and we're going to just take the tally in, you know, spot 10 and add 1 to it. That's all we're going to do. Okay. So let me just kind of demonstrate how this works. Okay. So right now I've got space tracking, which is completely blank. I've got player 1, which is empty. Oh, I need to create player 2. Okay, which is also a new player starting at go. Verbose is true. And so here I'll do set seed 1 just so our roles end out correct. So we're going to do take turn for player 1. Okay, and because I have verbose set to true, it does this. Okay, it says player at 1, player moves 5, player now at 6. Okay, and if I take a look at space tracking, we can see that position 6 now has a tally 1 because we've run our take turn, which takes the dice, it moves it, and then it increases the tally count. Okay, then I can do take turn for player 2. Okay, players at 1, we roll a 10, we move 10, and we're now at position 11 here. Okay, and then so if I look at space tracking, we can see position 11 now has a tally increased. Okay, and basically, and we can see, you know, where position player 1 is, and that's that. So here's a very simple simulation. Okay, I'm gonna just, maybe I don't want to do 100 games of this, but I'll do 2 games. Okay, space tracking, we're gonna just reset our reset our trackings to zeros. And inside here I've got a loop, right? So the innermost loop, we're going to take 150 turns. We're going to have it, and it says if player 1 is verbose, we're going to say player 1's turn, and then we take the turn. Okay, and then it'll do player 2's turn, and we take the turn there for player 2. We do that 150 times, and then and after that completes, the next loop just says we're going to do a new game, and every time we do a new game, we reset our players. And so running this loop will run 2 games of 150 turns. Are you guys okay seeing that? Okay, so I'll just we reset our space tracking. We've done this, and it's done. Okay, it was very quick, right? I mean, here let me do verbose is true. Okay, and this will just produce a whole lot of output. Okay, but you'll see it. It'll just fly by. Okay, and so this is all of our output after, you know, a whole bunch of turns here. Okay, and we can see somewhere around here, you know, it starts new game 2. All right, so player 1 is at 1, moves 4 is at 5, player 1 moves 8 is at 9, and then, you know, going back to player 1, it's at 5, move 7 is now at 12. Okay, and so we can go through this, and we can just kind of see what has happened. And so we can look at space tracking, and this is where all the spots people have landed so far. Okay, so so far I haven't implemented anything, so our space tracking should resemble the uniform distribution, right? Because they're just moving around in a circle. So after lots of turns, it should resemble a uniform distribution. You know, after only 2 games of 150 turns, meaning like 300 turns total, we might not have that. Okay, and so what I'm going to do is I'm going to just bind the game board, which is that data frame, right? So the game board is this data frame, and I'm going to bind the tally vector to it. So here's my results, which is this, and then we'll also, I'm going to put in kind of a relative frequency by doing each tally divided by the sum of the tally there. Okay, so sum of the tally, this I think will be, you know, a total of 600 rolls. Okay, and so here, if I look at the results here, it's kind of hard to tell. This is only after 2 games, and you can you know, you could even do a bar chart or something like this. Let me turn verbose equals off, and the way I have this written, this runs pretty quickly. Okay, so I can do 100 games, or yeah, we'll just do 100 games. We'll reset space tracking, 100 games of 150 turns for each player. So it just runs through this very quickly, and we can look at our results. This is what it looks like, and it looks fairly uniform. I can do bar plot results $tally. Okay, and it's fairly uniform right now, which is what we're expecting. And if I increased this from 100 to something even higher, I think the uniformity would be even more pronounced. Again, this is because I haven't implemented any of the rules regarding, you know, when you go to jail and what happens. And you can look online about space probabilities for Monopoly, and what you'll see is that because people get sent to jail a lot, the spots that come after jail have a higher probability of being landed upon, okay? Especially the ones that are kind of like in the even positions after jail, because when you roll doubles, you know, you'll get out of jail and things like that. So those happen. Okay. Here I want to show you how to use the manual dice, because this I think will be helpful as you're running these simulations. Okay. So here I'm going to do set seed, and so this means, so here I'm specifying these are the dice rolls I want. I want to roll a 6-4, a 5-3, a 3-5, a 6-2, and things like that. Okay. And here I've got verbose is true. So this uses the dice reference class, and the way the dice reference class works is it's, you know, it starts here, and then what it does is it just returns 2 of these things from the vector. So I'm going to rename my dice function. I'm going to create a dice function which is going to use the dice reference class here. Okay, and so what this will do, we're going to reset this. We're going to create a new player here. And so just taking, we'll say, 20 turns for our using our manual dice. So using the manual dice, the loop says, you know, we're going to do turn I. And you can see it's going to start with, you know, rolling a 6-4, and it prints out all of the things that player 1 does after rolling a 6-4. Okay, and then turn 2, you can see it takes the next 2 dice that I've specified, a 5-3, and then it rolls so a 5-3, and then a 3-5, and then a 6-2. Okay, so this way you can set the dice manually to kind of make sure things happen. So you can see if, you know, you can force it to do 3 doubles in a row to see if that truly activates going to jail. Okay, so as you're programming and you want to test out your code, I think the manual dice, you can go through the reference class that I've written for the dice, but you don't have to. Basically, what you want to do is you want to just program your vector of the rolls that you want to use here. You throw that in there. You're going to call a dice function to be set dice roll. Okay, and so when you run dice now, it's going to give you 6-4. It'll just keep going through the vector that you provided. After you run through too many, though, once you hit the end of the vector, it's going to give you an error, because it's going to say I've run out of these manual dice that you've given me. So setting the dice this way, you will run out at a certain point. Okay, so obviously you can't do this for the grand simulation, but it's very useful when you're testing out your code. Okay, I've also posted an example of what happens when you so using these dice, the 6-4, the 5-3, and the 3-5, this is just output from my code when I did it verbose for just one player. And so it says, you know, rolled 6-4, you move 10, you're at jail. Okay, tally at 11. And this shows you exactly where I'm putting tallies and things like that. You rolled a 5-3, you move 8, you're now at Tennessee Avenue, tally at 19, so on and so forth. And so later on you can see this is when I started rolling doubles, okay? So I rolled 4-4, you move here, I rolled 4-4 again because I'm putting in the manual dice. And so we, you know, take tally, roll doubles, take another turn, rolled 4-4, doubles count. So here I've got all of these things being very verbose. Doubles count is now 2. And then so at here, as soon as I roll 2-2, it says doubles count is now 3, and then now we're going to jail. Okay? And then now that we're in jail, we roll a 4-3, we're going to stay in jail, we put a tally at jail. Here we rolled 4-4, we rolled doubles, we're getting out of jail, and that's it. Okay? Because the rules are set so that when you get out of jail on a doubles roll, you don't go again. Things like that, okay? So these are all of the, I don't know, you can kind of go through this and see what happens, and this is kind of the vector of all the space counts at the end of this example. Okay, good luck everybody.